Hello everybody, this year's culminating task will be on creating your own musical instrument. So not only will you be creating it, you'll also be backing up with the math behind it so that you can predict what length each tube will be so that you can create the next successful note so that you can create a beautiful audio recording. All right, so the whole purpose of this lab really is to compare between the theoretical results and the actual outcome. So not only will you be building the musical instrument, you'll be testing the outcome with it against the numerical values that it should be at and seeing if the numbers are in unison with each other or if there's a significant deviation between the two. What do you need for this lab? First off, you need to start off with hollow paper rolls. The most important thing about it is that your paper roll needs to have an opening that's much smaller than the length of the tube. And that's a problem about using toilet paper rolls. Although they may seem to work all right at this length over here, if you keep on cutting it down any smaller, you'll get to a point where the diameter is larger than depth, and then the equations that you've learned in this course will not work out anymore. You're going to have a lot of deviations from it. All right, so the equations that we cover in this course only work if the opening is much smaller than its length. That's why the recommendation is that you should start off with a tube probably around this big, and then cut it down. So paper tubes are the best. If you have any sort of, Costco rolls like this guy over here, it works out beautifully as well. Okay. And do you need anything longer than a meter? You could, but you don't need it that long. Okay. Something like this is a good length to start off with, and it's just going to get shorter and shorter from here. Again, if you don't have any paper towel rolls or whatnot, you can take a piece of paper and carefully roll it up. The only thing about rolling it up this way is that when you set up all your rolls, make sure they all share the same diameter, because the diameter will affect the characteristics of the outcome as well. So just to maintain some form of control or consistency in all of your measurements, make sure that they're all of the same diameter before you start cutting them. Okay, so those are your options. Can you just use one roll? I suppose if you have rolls like what I do, I have one which is as tall as this room I was going to show, but that's okay. You could take that big one and cut it smaller if you want to. All right. So if you have one really long gift wrap roll, sure, you can just chop it down to 50 centimeters for the first one and go from there. Why do you need to cut it? Well, you are making an instrument, so you need to have multiple tubes. And again, it'll make a lot more sense when I get to that point in the explanation. Okay, so let's just go through this first, and then I think I'll answer the questions afterwards. Okay, so yeah, you'll need some hollow paper rolls, ruler. Of course, you need a ruler so you can measure everything and do your comparison. And then the third equipment, if you have your own favorite guitar tuning app or even a physical guitar tuner, as long as it tells you the frequency that you're generating the sound at, that's fine. It's perfect. You can use that and it'll work all right. No problems at all. There is a program that I do recommend that you guys use, and it's called TuneIt. And the reason why I recommend it is because this software has been perfected over almost 2 decades. So it works really well. And yeah, you have that amazing spectral analysis down below, so that just in case if it doesn't pick up the frequency properly, you can take a look at the numbers down below and figure out what resonant frequency that your tube is at. Because remember, when you blow through the top of this, not only will it resonate at its fundamental frequency, it does have its overtones as well. But we're only interested in the fundamental frequency. Okay, so effectively, what you're going to do is that you're going to create an instrument, and you're going to play it back, and then you need to have some sort of guitar tuning app, like the one I have on the screen over here, to compare your theoretical frequency with whatever that's observed by the software. Okay, so if you have your own version of tuning software, you can use it. TuneIt exists for PC, and it also exists for Android phones as well. So that's my recommendation. Okay. And paper and tape is optional. For some people, what they want to do is that they want to take their paper towel rolls and they want to their toilet paper rolls, and they want to stack them together to create a longer one. The only thing you need to watch out for is that when you end up adhering them on top of each other, that it's a nice, tight, clean seal. If there's any sort of weakness in binding or opening in it, it will ruin the experiment and it will not work properly. That was one of the problems I had actually with this guy over here. I was wondering one day, why wasn't this working? I was trying to do the demonstration in the class and I couldn't figure out why. And it's because there was a microfracture over here where I couldn't see it with the naked eye unless if I peeled this apart, but that fracture was enough for this not to resonate anymore. So that's the concern about taping the toilet paper rolls together. If you're not careful with it and you don't have a nice clean seal, or the ridge is too ripply, it's going to disturb the air as it flows through and it's not going to work. So my recommendation is to use solid cores, and your best way, if you don't have paper towel rolls, is to take paper and roll it up. Okay, so that's your best plan B if you don't have plan A already. Okay, so this is what you're going to do towards solving your lab. First off, you're going to take the longest roll that you have, because as you know, as a roll shortens up, the wavelength decreases. As the wavelength decreases, the frequency goes up. So your lowest reference frequency is that of your longest tube in your house. Okay, so you take the longest tube and you got to take the speed of the air before you do the next calculation. So how do you figure out the speed of the air in your house? Again, if you have one of those infrared thermometers, by all means, shine it against the wall and there's the temperature of your room. Most of us don't have that. I assume that we have thermostats in the house. So just go upstairs, or downstairs, look at the thermostat temperature. Maybe you want to do your experiment in that room as well. That way you're guaranteed the temperature. Okay, so in your givens, temperature, you have. That temperature will tell you the speed of sound based upon the formula of 331.4 meters per second plus 0.606 meters per second per degree Celsius times temperature. Okay, so your givens is that you'll look at the temperature of your room, use that to calculate out your speed of sound. Done. Number 2, you have the longest tube. The longest tube will tell you your value of L. And this is L1. Now, with regards to L1, this is a preference up to you. You can either have it as an open or a closed paper roll, depending upon the frequency that you want to generate. If you want a closed paper roll, cover off the bottom, and then you have a tube that abides by lambda over 4 for your first order of resonance. Okay. Now, if you keep it open, then you have lambda over 2, right? So lambda over 2 if it's open, lambda over 4 if it's closed. So it's up to you which one you choose. Okay. You may want to stick with the same consistency throughout your entire lab. So if you choose open, stick with all the tubes open. If you choose closed, stick with all of them closed. Okay. All right. Now here's where the algorithm comes into place. Okay. First off, this is your reference frequency. So now that you have your length and you have your speed, well, now you can figure out wavelength. Since V is equal to F lambda, then lambda is equal to V divided by, since V is F lambda, then F is equal to V over lambda. Okay, and as I said, with the tube over here, if you're dealing with it as an L1 order, then you have 1 over 2 lambda. L1 is equal to 1 over 2 lambda. So your L1 will tell you your wavelength. Your wavelength you can submit into here. The temperature will tell you your speed. And now you figured out what the resonant frequency of this is. Now, when you play the instrument, this is a problem that I see with a lot of students doing. They end up putting it in their mouth and they go, and that's not how you play this. All right, don't go off humming away at it. Instead, I want you to blow perpendicular to the opening. You probably don't want to put your mouth too close to it. You want it to be just a few centimeters away. And if you blow it at just right, you'll hear that the tube itself will resonate at one pitch. And with the proper tuning app, I don't know if it'll work well in this setup over here. I'll just try it out, even though this is a live recording. Mind you, I have my microphone echo sound canceling feature set up, so it may not pick up on this properly. But if it does, you'll see that it'll register one frequency. That high pitch is probably the sound of my furnace in the back. But I think earlier I saw around 300 hertz, and that probably is what it is. Again, you want to be in a quiet room when you're doing the recording so that you can, oh, it's getting quieter now. Okay, it's embarrassing while I'm doing it real time, but if it works out well, you may not need to practice a few times. You'll get a corresponding frequency for it, all right? And then that will be what you're comparing with, okay? So you'll have your calculated frequency. So you have your F calculated, and then you have your F from your tuning app, whatever that you're using, okay? Now, the calculated one is assumed to be the, what's the formula? Percentage deviation is equal to the absolute value of your theoretical value. All right, so your theoretical is down below. In other words, your calculated value, and it's by the difference between your theoretical and your experimental, multiplied by 100%. Okay. Okay, so the percentage deviation formula, it's part of the handout on your lab. If you go into Google Classroom, it's listed there as well. Okay, so that's how you can determine the percentage deviation between your calculated results and then the theoretical one, which is the one where as you blow that note through the microphone, I just don't have the best setup right now, it will pick up on that frequency, and then you'll do the math for it to see how far you are off. And I'm hoping that for the most part, you're within 10% of the right answer. I know that everyone's living in different circumstances and it may not be perfect, but as long as you're within 10%, you're probably doing the lab just fine. Okay, and then you'll need to create a few more adjacent notes. So the first one is based upon the longest one. Everything else is based upon a mathematical formula. In an earlier episode, we talked about the fact that in the equal temperament scale, the next adjacent note is based upon the fundamental note times 2 to the power of n over 12. Okay, so this is the generic formula to figuring out how to tune the notes in any sort of chromatic instrument, like a piano or the pan flute that you're working on. All right, now you're probably going to deal with the major scale. So you're probably going to deal with do, re, mi, fa, sol, la, ti, do. So do will be at your fundamental note, so your n will be at 0. Okay, so this is F is equal to 2 to the 0 over 12. And at 0 over 12, well, that's equal to 0, and 2 to the 0 goes to 1. So I hope that makes sense. All right, when you use the power 0, you're already at your fundamental note. To play the next note, you'll notice you need to go up 2 semitones. And that's why you'll see the number 2 for the re note. To get to the mi note, you need to go up 1, 2, 3, 4. And that's why for mi, the number is 4. To get to fa, you go up 1, 2, 3, 4, 5. Hope that makes sense. Sol is 7, and so on and so forth. All right, so I'm going to give you that value there for your reference for those that are not too familiar with music. Now, do, re, mi, fa, sol, la, ti, do, if you ever watched the musical Sound of Music, you know these are the basic notes that most songs are created upon. All right, so what I need you to do is I need you to create another 4 more notes. Many people will start off with the first 5 notes and think of a song for that. If you want to go extra and beyond there, you're more than welcome to. All right, so I do encourage you, if you want to go beyond 5 notes, please do so. Maybe it'll make the recording sound a lot better. And yeah, if you wanted to, you're more than welcome to do that. All right, so you're going to use this formula over here to find out the next corresponding frequency. Okay, because the first frequency we've already found out. Okay, once you've done this calculation over here, that is your reference frequency. That reference frequency you'll be subbing into each of your Fs. So you'll be using this equal temperament formula to find out the next corresponding frequency. Okay, and now that you've figured out the frequency of the tubes, then you can do the reverse calculation. Okay, so in the reverse calculation, now you know the new frequency. Okay, so for example, let's say that your F of your, I don't know, your sol note, when you calculate it out, it worked out to, let's say, 100 hertz. I'm just using a random number. You're taking it that you're still in the same room. And if you're still in the same room, you already have the speed of sound. That's at whatever that numerical value is. Okay, in fact, I'll just leave sol at some random number. So F sol, you know, from the mathematical calculation of 7 over 12, that's what sol will be. Speed of sound is still the same. And the tube, now you're trying to figure out the tube, but is it open length tube? All right, so remember, you're still using the formula L is equal to 1/2 lambda. So with these two values over here, since V is equal to F lambda, you isolate and solve for lambda. So lambda is equal to V over F. Okay, so you have your V, you have your F, you solve for your lambda, you sub the lambda into here, and now you know the next tube length. And you'll rinse and repeat with this with all the rest of your notes. Okay.
Oh, so you cut the tube.
Your musical scale. Sorry, student has a question?
Then you cut the tube by that length, right?
Exactly. That's why you're doing the math. So the first one you do not cut because the first one defines all the rest of them. All right. So this is your definitive value. From there, you're going to take that to create your reference frequency. Everything else is based upon the reference frequency. What do you mean by finding next 4 notes? You're finding out re, mi, fa, sol. And if you want to use la, ti, do, that's up to you. Some people are wondering, do you need to do all 8? No, you don't have to. All right, but the minimum that you need to do is another 4 more because you need to have 5 notes for the full marks. Let me show you the mark breakdown in the next slide. I think that's what it is. Everyone's wondering about how am I marking and evaluating this. So we'll save this for the next slide. Okay, again, all links to the software is already available in the Google Classroom. Take a look at this assignment and it's listed there. Okay, so again, you're using the algorithm to find out the next adjacent notes, then you're reverse calculating to find out what the L1 order is for all the other notes. After you're done with that, again, you want to use the tuning app, whatever it may be, to compare between your theoretical values and your actual value. Okay, so yes, you'll be marked for your percentage deviation calculations. You'll also be marked for your length calculation if it's correct, as well as a few other calculations as well. So the mark breakdown is already available in the description, right? If you need to take a look at it. And if you do everything all properly and you have it all incorporated into your music video, that's how you can get 25 out of 25. Okay, so I do need to see each of these notes incorporated into your song, whichever ones that you decide to make. How should this look like? Well, here's an exemplar that I got from a student from last year. Does it have to look like that? All right. I have seen students where they just picked up their roles one at a time and tried to go at that. If you can handle that, because you're only dealing with a few handful, you can. But as you can see with that composition, it makes it so much easier if you design it as a pan flute. Now, as a reminder, guys, don't blow it into the tube. Blow perpendicular and separate by a few centimeters, and that'll allow it to resonate the best. Okay? How many notes do you need? As I said, here is the mark breakdown. Minimum requirements is 5 notes. If you want to go above and beyond it, you're more than welcome to.
Do we still get the
Yes?
Do we still get the incorporated into a song mark if we only use it once for that note?
You can use it once. That's okay. Some songs just use that note just pops up once in it. That's fine. Okay? Is that a 25 out of 25 exemplar? Yes, no. You got to watch out. I'm not marking you by the video, okay? Your video is only 5 out of the 25 marks. The rest of it comes from the calculations, and I'm glad that that student is a model student. He did show everything properly, so he got all his marks from his efforts of showing everything, okay? So that's what I expect for you in this lab. Now, again, the grade that you want is up to you. If you really want to have a minimum of 3 notes, just so you can get a 76%, I'll let that be up to you. If you're aiming for 25 out of 25, then please work through all the 5 notes. Remember that this is worth 20% of your final grade. So I think for most people, you don't want to take any shortcuts and you want to go for all 5 notes. And if you want to go for 6 or 7, please show the math and maybe I'll keep that in consideration in your mark as well. Any other questions? Can you make up a song? Well, there could be an international song that I'm not familiar with. So as long as it sounds like it's musical, I'm okay with that. Okay. Any other questions, guys? How long does a song have to be? Well, if you're aiming for Mary Had a Little Lamb, that's probably only 30 seconds right there. That's fine. Yes, I do need it as a video recording. The reason why is I need to make sure that the author is from you and that you're playing it in the proper order. That's all. So when you upload the file, not only are you uploading all your calculated results, you're also showing a short little video, just like how this student did. That way I can confirm, looking at it as well as running my app in the background, that everything is all jiving together. Okay, which notes do you want? Again, I'm going to leave that up to you. And that's the reason why I just left you with this generic formula. Okay, if you want to go an octave above, then really take these frequencies and as you've learned already, double it. That's how you go 1 octave above. The same numbers, just double that value. Okay, please tell me which song you use. That way I have a reference for it, but that's okay. Some people have their own renditions of it. Okay. Now, with regards to recordings, hey, I'm only seeing 1 recording at the end, so you can take as many takes as you want, and once it works out, ideally, that's the one that you'll submit up. Sometimes what I do, in fact, let me just find out what the app is called. You'll just record everything all at once and you won't hit the stop button, because I know stopping and starting takes forever. So you'll set up your equipment and you just keep on playing and playing. And once you got it just right, you can crop it. There is a program and it's called Lossless Cut. Literally, it's called Lossless Cut. All right. I can open it up. I don't have a website for it. I just know that that's the name of the app. And once it shows up, I can show you what the interface looks like. And it's one where what it does, here it is. It's a very cute looking interface. You drag the video in here and you can delete off everything from the beginning. You can delete off everything from the end. And that's a quick, free way for you to crop in whatever is the video that you want to upload. Okay. Again, it's called Lossless Cut. Just look it up online. I don't know the website. Does help tell you? I have no idea. Learn more? No, about. Lossless Cut. This is what the website is. Okay, sure. MyFi.no lossless cut. There's the website. I didn't even know that. Okay, I just knew the software. This one works out well. And yeah, there's even a Mac edition as well, where it's just going to crop your video so that you can send what you need to send. Okay. And remember, guys, that yes, in this particular year, it is due on June 28th before 3:30 p.m. If you want to work on it over the weekend and submit it on Monday, you're more than welcome to. In fact, I encourage it because, as I said, next week there's a lot going on, so you probably want to clear this. This is also the same reason why I'm covering the instructions today, so it just gives you more time to get this done. That way, even tomorrow, I can answer any questions you guys might have. So are there any other questions about the lab right now before I shut and end off the recording? Please ask away.
Can you just show us how you blew the paper roll perpendicular?
Okay. Remember that you need to blow perpendicular to it like this. Okay, you're going to blow perpendicular. Don't blow right into it because it's not going to resonate as well. Okay, you want it so that an anti-node forms up here, and that's why you're blowing perpendicularly. And as the air pressure goes in, it's going to resonate back and forth and create just that one pitch. And you'll notice that the pitch is dependent upon the length of the tube. You'll also notice that whether if it's open air column or if it's closed air column, it does change the frequency as well. All right, how do you make the instrument? As I said, some students, they just held it with their hands and they moved it back and forth. If you want to be like my student over here, that person just taped it together afterwards. I'll leave that up to you. Can you have one closed air column and one open air column? If that's part of your composition and those notes are required, then that's perfectly fine with me. Okay, so if you want to do it that way, with some are open, some are closed, show that in your calculations. And if the song incorporates it properly, that's one way where you can get away with one tube doing two different notes, or one tube length getting away with two different notes. That is true. Okay, so for example, if you need one note that's one octave down for any reason before the tonic, then that's one way to hack it to make it happen. Is there any other questions? I see a hand raised up, but I don't know if there are questions you want to ask. Remember, this is all being recorded right now.
I'm using toilet paper rolls, so would you recommend me like taping 2 together or 3?
You could start off with 3 and then cut down from there.
Okay, thank you.
Yeah, you could start. I'd say start off with 3 because again, all the rest of the notes are going to be significantly shorter than it. In other words, you know, your re, mi, fa, sol, those are all going to be 2 paper tubes long, right? So the first one will be 3, but the rest will quickly drop down to just 2. Again, if you want to use regular pieces of paper, you can use regular pieces of paper as well.
Okay, thanks.
Okay, how many do you need to make? As I said, if you want to get an aim for your 25 out of 25, then you'll need to do all 5. If in your heart, all you're concerned about is getting 76%, if you do all your calculations properly up to this point over here, then yeah, you could get your 19 out of 25. So I'm going to leave that up to you. Okay, you can work as little or as hard as you want for the grade that you desire. I hope that everyone's aiming for the stars, but everyone has their own prerogative. Remember that do, re, mi, or Mary Had a Little Lamb is just 3 notes. So you have to figure out how to incorporate another 2 notes into your song as well. It could be backbeat notes if you need that to be.
Wait, Mr. Nee, do we glue the rolls together to make the instrument?
Again, if you want to glue them together, it's up to you. I just answered that question. If you want to glue it, you can. If you want to hold them separately, I've had students that just picked it up from the table and played through it. Okay, I don't expect anyone here to be a perfect instrumentalist with this. So there's a little bit of delay between the notes. That doesn't bother me at all. All right, it should be a relatively decent performance, but it by no means does it have to be pitch perfect. Other questions? Yes.
So when we first, oh, you can go first.
No, it's alright. You can go. I think you were first.
Yeah, okay, anyways, it's quick. So when we first figured out the first frequency, we blow sideways. I got that. But when we play the instrument, is it also sideways or is it in? It's also sideways.
It's always perpendicular, not sideways.
Yeah.
Perpendicular.
Yeah, perpendicular.
All right. As I said, could you make up a song? I wouldn't know if the song's made up if it's international, but it should resemble a song that you play at the end. Other questions?
For like, if you were to do Mary Had a Little Lamb, could you do like half of it like the regular do re mi, and then the other half be like 3 other notes or whatever, or like, because as long as it's like in the same order, kind of, wouldn't it still sound like Mary Had a Little Lamb?
Now, I don't want to talk too much about different modes of playing, right? You can either play in your Ionian scale or your Dorian scale, and if you really want to go through that level, you can and change the mood of the song. But if you ever play Mary Had a Little Lamb on any of the other modes, it doesn't sound natural to the human ear. Okay, it sounds a lot more moodier, and if that's what you're going for, then that's what you're going for. You can try it on your instrument afterwards. Okay, on a piano, things sound right when the separation between the notes are a certain way. For example, since I have it over here, here's Mary Had a Little Lamb in the Ionian scale. Okay, there's Mary Had a Little Lamb in the Ionian scale. If you want to do Dorian, it sounds kind of weird. All right, that's the consequence if you decide to scale up. All right, if you want to modulate and then do it with sharps and flats, I'll leave that up to you. Remember that I'm only giving you the numbers just for the major scale. If you want to do the sharps and flats, just count the number of semitones and use those numbers. Again, that's going way too much into music theory, which I don't really want to go through in your resonance column project. All right, so if you really want to go to that next level and tell me that you're using it, go nuts. I'll be happy that you know that stuff, but by no means do I expect anyone to know that level. Any other questions?
If we're using like one big roll of like, say like if rep, so like 1 meter, how much should we cut our initial like toilet paper roll?
I would say, you know, start off with the longest one at 30 to 40 centimeters and go from there.
Okay.
That you have enough to spare for the rest. Okay. Yeah, 30 centimeters would probably be ideal. And again, if you need to do any paper napkin math, go ahead and do that, right? See what happens at 30 centimeters and do all the math for the rest of them and see if you can actually get it to all fit in your length.
Also, another question, how long should our song be?
Less than a minute's fine.
Okay, thank you.
Okay, as long as I can hear all the notes incorporated in the song, probably 30 seconds is an ideal length. Okay, it does not have to be a 3-minute long repertoire. Where can you find the example of the questions? As I mentioned, guys, this is all available in Google Classroom. All right, so you would go into your Google Classroom. Let me just find it out over here. Okay, and this is lesson 6.06, Resonant Columns at Home Lab. This is where you're going to be uploading it. Again, the Tunit software is available here, and the instructions are available here as well, along with all the formulas. Okay, and that's where you're going to upload everything as well. Remember that there's 2 things to upload: your calculations as well as your video recording. Just your homework is relevant to this. Okay, there's no other practice questions other than doing this raw. That's why this is a practical assessment. Okay, this is your culminating task. Now you're applying the theories that you learned in class along with what happens in reality and seeing all that magic mashed together. Any other last questions, guys, before I stop the recording? As most labs, again, what you're doing is that, again, you'll start off with your name, your collected data, all your calculations, your percentage deviations, and just make sure that you answer them all within the same category. All right, so you're going to start off with your dough note. Tell me how you arrived at that frequency. Tell me your percentage deviation. Move on to the ray note. Show me your calculations. Show me your percentage deviations. And just keep on going back and forth from there. And that's all I really need from the collected lab data. Okay. So I just need to do the analysis of your calculations and how you got to those answers. Yes, another question. Please ask.
Hi, just a quick question. So we get to decide the starting length of our dough?
Yes.
Okay, thank you.
All right. It's all going to be based upon what you have lying around your house. So one student was asking how long should be when it's a meter. I don't know. I would just say, start off with about 1/3 of the length of the full tube if you're using it and start going from there. Or maybe a quarter, somewhere around there. Either a third or a quarter. I'm just earballing it, if that's even a word. Okay. Any other questions, guys? Yes, please ask. Again, we're under a recording right now, and it's getting rather lengthy, the recording.
Oh, so I was just want to confirm that do we decide the length of our dough, or do we calculate the length of our dough?
You decide yourself.
So it doesn't have to, the first one doesn't have to be calculated out? It can just be...
Remember, you're starting off with whatever you have lying around. For example, if I have this around and this is my longest length, then I'll take out my ruler and I'll measure it out. So this works out to 40 centimeters plus 10. So this one is 50 centimeters. So my L1 is equal to 0.5 meters if I had this lying around my house. This defines my dough note. And my re, mi, fa will all be shorter than this.
Oh, okay, got it. Thank you.
Okay. So again, that's why your longest tube you can find in your house defines it. Some people want to take a long strip and cut it down. The problem is that you may run out of parts, and that's a risk on your behalf. You'll have to sit down and calculate out and figure out how to scale everything yourself. Okay. Just like what you need to do before you go to Home Depot. If you buy a 4x8, you better sit down and do all the math first on how you want to get all your free cuts in there so you can build your bookcase or shelf. That's your homework on your behalf. Okay, yep, calculations on all 5 rolls, percentage deviations, sample recording. As long as everything's all done properly, that's how you get your 25 out of 25. Any last questions before I end off the recording? Please ask away.
So, by percentage deviation, is that uncertainty?
No, it's your percentage deviation.
Or no, like
recording.
what?
Okay.
Sorry?
It's a difference between...
Sorry.
Yes, it's a difference between what you got versus, what you calculated out versus what you got. The TuneIt app, once again, is to compare between your calculated frequency and your response frequency. All right. So let's say that your F calculated worked out to, I don't know, 534 hertz. Okay. Meanwhile, the frequency due to the TuneIt, which is your experimental, was equal to 538 hertz. What is the percentage deviation between these two? Again, as in your notes, percentage deviation is equal to the absolute value between your calculated versus your experimental, all divided by your calculated or your theoretical. I'll just write down theoretical. Okay. Because remember, your calculated value is your F theoretical. That's what you theoretically think the value should be based upon your conditions, right? So this is the number you're expecting, but what did you really get from your experiment? And that's your TuneIt experimental value. Multiply by 100%, make sure it's absolute value because percentage deviation should never be a negative value. Okay, and that's how it's done.
Okay, thank you.
Okay. So I'll leave it with that. If there's nothing else, I'll end the recording. One more text comment? Sure. How would you determine your theoretical frequency? Again, you need to sit down and calculate it all again. I started off from the beginning already, okay? So that's why I recorded this so that we can go and watch this again if you need to, okay? So remember, it all stems from all the way back here. Based upon your thermostat temperature of your house, determine the theoretical fundamental frequency. Okay, that's how you do it, okay? So watch back to the beginning of the video and you'll see it. I've already announced it. Probably about 20 minutes now because that's how long the video is. So any other questions, guys? Because no one wants to watch a half-hour video. Okay, I'll leave this as the recording, and that's it. Good luck on your lab.